This portion of the course, we're going to learn about similarity related to triangles. And part of that is going to relate to some computational skills involving working with radicals. So I figured it would be a good idea to go over how to simplify radicals, at least in the early going, just so it's, one of those things where we're all on the same page, moving forward. Right. So radical expression has that radical symbol, and the value under it is known as the radicand. If that number can be broken up into two factors, one of which is the largest possible perfect square that can divide evenly into that number, then you got it. Then you have the means by which you could simplify your radical. All right. So what I did was I made a list of I wrote it as the popular perfect squares. What I did was I listed the first 12, 13, 14, 15 perfect squares. And then after that, the more popular ones beyond. So, 625 is the square root of 25, 900, 1600, and 2500 are all basically, if you look at 9, 16, and 25, those square roots would be 3, 4, and 5. It's just a matter of also tacking on the square root of 100, which is 10, so 30, 40, and 50. All right. So I'm going to take us through a couple of these examples. I don't want to go too crazy because I want to give you an opportunity to practice some of them on your own. But for now, it's just a matter of identifying, or at least going through the different possible cases, so that you can get a feel for, what I'm looking for. So we have the square root of 50. Square root of 50 can be broken down into the product of two factors, the largest of which is as a perfect square. If I'm going through my list here, 1, 4, 9, and so on, looking for values that divide evenly into 50, the largest one out of that list that'll divide evenly into 50, it would be 25. All right. So then what I would do is I would take my 50, divide it by that 25. That gives me 2, and that tells me what the other possible factor would be. All right. So then what I would do then is take the square root of 25, which is 5, and then carry down that square root of 2. Square root of 2 I can't do anything with. It's a decimal value. All right, I might look at my list again and say, well, is there a perfect square that could divide evenly into 2? And the answer is, well, yeah, 1, but that's the trivial case. That's the case that doesn't really accomplish anything, because 2 divided by 1 is 2. It's not going to get me anywhere. All right, so what I'm going to do is just bring down that radical 2, and this would be our final answer. All right, radical 108. Same idea. You're just going down the list here. You see we got a 1. 1's never going to be a helpful value because it doesn't advance the cause. If I divide 108 by 1, it's just 1 and 108. All right, so that's no help. 4. All right, 108 divided by 4. Oops. 108 divided by 4. 27. Okay, so it divides evenly, but let's keep going. 108 divided by 9. That also divides evenly. 108 divided by 16. That one I would eliminate. 108 doesn't divide by 25. How about 108? Oop, I am struggling here. 108 divided by 36, 3. All right, so we had a few different values that divided evenly into that 108, but what I want is the largest value that divides evenly into the 108. All right, so as it turns out, it's the square root of 36 and the square root of 3. Square root of 36 in my calculator, 6. Square root of 3. This is, for a lot of us, this is unnecessary work, but I'm just doing it to show you the nuts and bolts of it. Decimal value. None of those values are going to meaningfully divide evenly into the 3, so we're just going to leave this as 6 times the square root of 3. Also, we would call this 6 radical 3. All right, so that means the same thing. All right, so I'm going to skip number 3. I'll leave you to do that. I'll put a little star on it. square root of 200 divided by 2. All right, numbers 4, 5, and 6 are the same kind of general theme. What we're going to do is we'll look at, I'm going to go yellow for those keeping score at home. What I'm going to do is I'm going to break up that radical 200 into its separate factors. And again, going down my list, I got 1, 4, 9, 16, 25, 36, 49, 64, blah, blah, blah. What would be the largest possible perfect square that would divide evenly into that 200? Right? Meaning, when I divide 200 by that number, it gives me a whole number as a result. Exactly, 100. Yeah, very good. So 100 times 2 is going to give me 200. So the square root of 100 times the square root of 2 is going to give me the square root of 200. All right. Square root of 100 is 10. Square root of 2 I can't do anything with. So the top of my fraction, the numerator, is going to become 10 times the square root of 2. The bottom is just a 2. Now, again, looking at it, I can see that there's a little bit more to this because I got a 10 here and a 2 there. I would want to be looking at that and say, you know, just forget about the radicals. Can I just divide 10 by 2? Sure. 10 divided by 2 is equal to 5. So this goes and simplifies down to 5 radical 2. All right. There's a nice way to check your work. I don't know about nice. It's easy. Take the square root of 200, divide it by 2. You get that decimal. And then take your final answer. You know, depending on the calculator you have, it might be a little bit different, but you should get the same decimal value. If you did, then you can feel confident that you did it right. If not, then back to the drawing board. I'm going to put stars on 5 and 6. Honestly, the rest of the way, it's pretty much the same idea. So I'll put a star on number 8 also, and I'll do the remaining 2 problems for you. All right, so here again, we're just looking at the radical component, the radical 72. Break it up. Looking at my list, the largest number that's going to divide evenly into 72 would be 36 times 2. Square root of 36 is 6. We have 6 radical 2. But we also had that 2, that coefficient of 2 out front. All right, so that's going to come along for the ride. All right, so here we're going to multiply only the rational numbers together. All right, so I always kind of say it as regular numbers can multiply by regular numbers, radical numbers can multiply by radical numbers, but you can't mix the two. All right, so this would be 12, but then you're stuck with the radical 2. The last one, number 9, it's really no more difficult. It's just you have, you know, it looks a little bit more intimidating because we got a fraction surrounding it. So 52 is going to be the product of something and something else. So I go to my list. Does 1 go into 52? Sure. Is it helpful? I don't know. I don't think so. Definitely not. How about 4? So 52 divided by 4, 13. All right, well, 13 is a prime number. You're not going to divide evenly the 13 by any of the perfect square values. So it looks like we have it. So 4 and 13. So I'm looking at 2 radical 13 is the simplified form of the radical. All right, but around that, I'm going to build it out using the remaining information. I have a 7. And I have a 2. All right. I have a common 2, top and bottom of the fraction. So 2 divided by 2 is equal to 1. So I can cancel those bad boys. Boop. And another boop. And I'd be left with just a 7 radical 13. And there it is.